Hello there, I'm Thomas Hatsios, the British-American pilot flying the Boeing 777-300ER in tonight's flight from Zurich International Airport all the way up to the Switzerland and Germany, and then coming back to Zurich International Airport runway 14 for an ILS localized landing. So right now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300 ERX of the PMPG simulation and the Microsoft Flight Simulator X. So I'm gonna start showing you the instruments inside the cockpit and other functions of the Boeing 777-300ER. I'm also, after that, I'm gonna show you the thrust levers, the engines function, the flight controls, how to steer the aircraft, how to have flight controls in flight, how to have directional control of the aircraft in flight, and how to use the autopilot flight director system panel, the flight management computer, create a route for navigating the aircraft, flight plan using the flight management computer. And then I'm going to show you the overhead panel, the electrical system, the batteries, the IDGs, the great drive generators, the ADIRU, the air data reference unit, the flight control computers, the hydraulic system, the fire extinguishers, the electronic engine control, the fuel system, the fuel pumps and fuel tanks, and the fuel jets. And I'm going to show you the wing and engine guides, the cabin pressurization, and the bleed air from the engine and the APU. And then I'm gonna make an engine start demonstration. I'm gonna start the engine to make an engine start, and then set up the flight plan. So I'm gonna set up. I'm gonna start with the displays of the Boeing 777-300ER airplane. So right now you can see here we are inside the cockpit. You can see the displays. We have the primary flight display with the flight mode annunciator, the navigation display, the upper ACAS and the lower ACAS, the flight management computers, the left and the right, the autopilot and flight director system panel. We have the thrust levers here, we have the overhead panel here, we have the electrical system, the hydraulics. I'm gonna show you the electronic engine control and the fuel system, and the cabin pressurization and the pressurized air system from the engines and the APU, and some other systems like the engine gun, the ice, the flight control computers, the ADIRU, the air data reference unit, the rammed air turbine. We have the APU, the auxiliary power unit turbine. So this is the flight control. So I'm gonna show you also the control yoke of the Boeing 777 and the rudder pedal. So you have the control wheel, the control column. You can climb the center bank roll. You can change the direction. I use the thrust levers also. So I'm gonna show you the general management of the aircraft, also the autopilot and flight director system panel, how to set up the autopilot. Here the speed guidance, the heading guidance, the altitude, the rate of climb and descent. We have many modes. So I told you about the primary flight display. You can see the airspeed displayed, and I'm gonna start with the primary flight display of the Boeing 777-300ER. It displays the minimum airspeed, the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director system panel, the barometric altitude above sea level, the barometric pressure of the outside atmosphere, also the rate of climb and descent, and the target altitude we set from the autopilot and flight director system panel. The target airspeed and altitude are displayed with purple, and also the target heading. We have the magnetic heading also, and or track, and we have the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the globe. So we have the ADIRU, the air data and reference unit. I'm going to show you it controls this data, the inertial reference, the air data like the airspeed and the barometric altitude, the rate of climb and descent. It controls the pitot static and the pitot dynamic tube sensors and other systems like the GPS receivers, 2 or 3 GPS receivers, the radio altitude above the ground level, also displayed in the primary flight display. And also we have the gyroscopic acceleration and acceleration rates using the laser gyroscope. And the inertial positioning, we have the attitude display of the aircraft, the pitch slider in degrees and bank angle in degrees, also displayed from the ADIRU, the air data reference unit. We also have the angle of attack of the aircraft. So this information we also display are being displayed using the ADIRU in the other systems like the navigation display, the flight management computer, the autopilot and flight director system panel, and the thrust levers, the FIDEX system, the full authority digital electronic control of the engines. So I'm gonna show you all these things. Also we have the navigation display, that displays the inertial reference position, the GPS position of the aircraft, the ANP and the RNP, the acquired navigation performance and the required navigation performance. We have also a magnetic heading or track. We have again the magnetic north pole and the true north pole. We have the GPS map and the terrain map. We have the weather radar and the terrain reflections from the weather radar, so you can see the terrain map image in the navigation display. Also with the airports, the distance from our aircraft. We can see the waypoints, the nav aids, like the DNDBs and the ADS and the VOR stations. Showing the terrain, you can see the terrain levels displayed with green, yellow and red. And also we have the silver lakes and rivers. We have again the magnetic heading or track. We have the wind speed direction and magnitude, and the next waypoint we're going to go over. So we can see also the runway that we are going to use for takeoff or landing. We're going to set up our route using the flight management computer from the takeoff runway and departure airport all the way to the destination runway and airport. And we're going to set up some intermediate waypoints for the autopilot to follow later on in vertical fixes, and also we can follow them manually. So I'm going to show you also that. Then I'm going to come to the autopilot and flight director system panel. I'm going to show you the autopilot engage and disengage switches, the auto throttle left and auto throttle right engage and disengage switches. We have the flight director engage and disengage switch. Also we have the indicated airspeed or Mach select knob. You can select the airspeed for the thrust systems for the auto throttle and the auto thrust to command the engines depending on what we need, or you can change the thrust levers position automatically. So you can see the thrust levers move automatically in the Boeing aircraft, not like the Airbus aircraft. We have also, besides the airspeed select knob, we have the auto throttle, the the hold switch for fixed thrust or variable thrust modes. We have the glide continuous and the flight level change mode. So we need to climb, we use maximum climb thrust, we have fixed thrust mode, and also when we descend we have idle thrust, fixed idle thrust, also fixed thrust mode. When we cruise or when we approach and land, we use variable thrust mode using the autopilot and auto throttle. So we use the speed mode of the speed guidance of the aircraft. So you select the airspeed with the speed knob, airspeed select knob. We have the LNAV and the BNAV, the lateral navigation, the vertical navigation of the aircraft. We have the bank angle, limit hold switch, and select knob for the heading of the aircraft, and the heading hold switch. We have the vertical rate of climb and descent of the aircraft is 1000 or 1000 feet per minute. I'm going to show you also. We can select the flight path angle in degrees, trigonometric degrees, or in hundreds, tens, and thousands of feet per minute. We can select the target altitude using the altitude select knob, and also the altitude hold switch. We have the approach localizer for an autoland of the autopilot and flight director of the Boeing 777-300ER airplane. This beautiful aircraft. So we have also the warlock switch in the autopilot. We can use the Lszh localizer function. So you can see here we have, as I told you, the primary flight display. We also have in the attitude display, we have the autopilot crossbars. We have the flight director crossbars in the Lszh localizer crossbars, and the flight mode annunciator with the autopilot and flight director modes, and the auto throttle. So I'm gonna start showing you these systems here. Then I'm gonna show you the thrust levers and the flight controls. And then make the engine start demonstration. So you can see also an exterior view of the Boeing 777. You can see. So we have about an hour left for this flight. So you can see here's the primary flight display that displays the information we need for flying the aircraft. You can see the airspeed indicated here. Right now the minimum airspeed indicated is 30 knots, but the actual ground speed is 0. We have the airspeed selected from the autopilot flight director system panel. So this grid is tape is the airspeed tape. This is the altitude tape. So I'm gonna show you also that airspeed selected 200. Here we can change the airspeed we're gonna use after takeoff, the heading and the altitude, and the rate of climb and descent. Here also you can see the modes we're gonna use. I'm gonna show you from the autopilot and flight director system panel. Also the FS panel, you can select the barometric pressure. I'm gonna show you now. So you have here also the barometric altitude above the sea level. Right now it's 1430 feet. The rate of climb and descent tape 10,100 feet. We have the altitude indicator with the flight director crossbars and the autopilot crossbars, and the pitch ladder indicates bank angle limit, and the Lszh localizer, the radio altitude above the ground level 2 feet, and we have the magnetic heading here is 300, approximately 320 24. So we have we can select a different heading here. We have it 360. So we have the barometric pressure altitude of the outside atmosphere is 39.92 inches of mercury. We have the angle of attack of the aircraft and the flight mode annunciator here. So you can select inches of mercury, you can select hectopascal, you can select also the meters, display the meters, display over here the altitude in meters. You can see we select we are right now position is 436 meters or 1436, 3000 meters. Select the altitude for flying. So we have select now hectopascal. Instead of 1013 hectopascal, we can select again inches of mercury. 29 using the FS panel here, electronic flight instrument panel. So we have 39.92 again inches of mercury. So you can see here the terrain, the navigation display that displays the terrain. You can see the terrain level displayed with red 6100, with green is 0 feet, and the intermediate is yellow. You can see the Switzerland here that we are positioned, the Swiss Alps, and our own airport and aircraft, and the direction of the aircraft using the magnetic heading right now. So you can see the magnetic heading, this line. You can see the distance, the rings, and also magnetic track or heading, and we have the RNP, the required navigation performance. The required navigation performance you can see here. I told you this is Switzerland, this is France, and this is Germany here, this area. So we're gonna be overflying Switzerland and some Germany a little bit. Some lakes. So you're gonna see later this map. I'm gonna show you the route also. We're gonna use the flight management computer to create a route later. You're gonna see it displayed in here. So I'm gonna continue with later with the thrust levers section and the overhead panel. So I'm gonna show you now the autopilot and flight director system panel. So you're gonna see the auto throttle. You can see the left and the right, either one system. We can have the flight director on and off here, so you can see this on and off. So we have the flight level change here. We can select another mode. We can select the flight level change, select the airspeed for takeoff, after takeoff to be around 250 knots. So if we can select by turning off the flight director and then re-engage it. So we will select also, we have the LNAV and the VNAV, the climb continues, and the auto throttle, the speed guidance of the aircraft. I'm gonna show you the autopilot disengage. We have the bang angle in degrees here. You can select a different heading here. So also this is heading and track here. Select. We can select the hold for this. We can deselect it like this. We can select an altitude different than the one we have selected already. Select also the hundreds or thousands, so we can select the hold here, whatever we like. So we right now have the track hold and the flight level change and the flight director like this. So we can select heading hold and flight level change speed. We can select the altitude hold instead of flight level change. You can select also the autopilot on and off. We have selected the autopilot now on. So you can see the AP is connected here for this altitude, this airspeed and this altitude here, and 7,700 a heading hold and altitude, and we have this heading here displayed also with Marcelo. So I'm gonna say it again. I can disengage the autopilot like this. So it engage, disengage. I'm gonna show you again. So if I press this switch here, we will disengage it. You will see the warning coming here. You will see the autopilot is disconnected. So we engage the autopilot again, like this. We can use this switch here also to disconnect it, or move the flight controls like this. I will disconnect the autopilot either way. So we have again the autopilot disconnect, the warning here. You can see autopilot disconnect. So maybe I reconnect this again. I can use this connection here, and also use another mode here. We have the VOR localizer, the auto land. We have I told you the heading we can select the vertical speed here or flight path angle. So we have a flight path angle like this. We can descend like 2.8, 3.2 or climb. This is trigonometric degrees for climb or descent. So you will see the flight path angle here, the FPA like FPA flight path angle, flight level heading hold and autopilot. And again we can change feet per minute using this switch over here. We can descend like this, like or we can climb the other way. This is the slider we use for climb and descend. So we can use this for climbing instead. So you will see the vertical speed now, and we have to climb like this with this rate here, the vertical rate of climb descent. So all this information I told you is being provided. We'll disconnect the autopilot again, cancel the warning, use the flight level change, maybe speed. So all this information is being provided in the overhead panel in the displays from the ADIR over here, the data necessary reference unit. I'm gonna show you small switch over here. I'm gonna show you also the engine. So we have the ADIR, the air data I told you. We have this view of the overhead panel again and the cockpit here, so you can see. So we have the thrust levers again here, you can see. Something like the flaps and so I'm gonna show you later. We'll be having some time, so you can see. I can move the thrust levers, the thrust will increase, so decrease them. So we have also the speed brakes here again. You can extend the speed brakes. You will hear the warning. We have the parking brakes down and up, and also we have this CNDR. This is the horizontal stabilizer chain disconnect. I'm gonna show you later from the other side view. The flight management computer also. The fuel control for the engine, for fire extinguishers. So we have again this view of the autopilot here. This is more flat view, and the FS panel here. Again, the displays here and here. So this is the general view of the cockpit. We have again this, you can see. So if I come here in the overhead panel, you will see some functions. You will see the APU here. We can turn the APU later on. The ADIR, maybe we can turn the APU now on and just have it on the start position. We're gonna use it for starting the engines later. You can see the left and the right electrical from the engines, the IDC drives, and we have the batteries here. So this is a primary flight control computer. We also have the ADIR, the air data and necessary reference unit that displays all this information here that you see, like the airports, the waypoints, the airspeed, the altitude, the rate of time to descend, and the altitude of the aircraft. We have the laser gyroscopes, all this in this small switch here, the ADIR air data and necessary reference unit. We have the primary flight control computers and the thrust asymmetry compensators. Some other systems, like I'm gonna show you in the overhead panel. We have the hydraulic system, the pumps also, I'm gonna come later. We have some lighting, we have the windshield wipers, the window heat, the passenger assist, the ground proximity runway override, and cargo fire and APU fire. We have the engine, electronic engine control and start system here, the fuel jets from the fuel pumps here, wing and engine applies, the pressurization, cabin pressurization bleeder, we need for starting the engines. Press right there. So I'm gonna show you these systems later. The fuel tanks, left and right fuel tanks. So some circuit breakers and so this is the general view of the cockpit. So I'm gonna come here now again. I'm gonna come here in this view, the virtual cockpit view. So we have a few more minutes to go. So you can see here this displays is the upper and the lower ACAS, engine indication and crew alert system display, and the thrust levers. You can see the thrust levers as well as the horizontal tail trim and the stabilizer of the tail. You can see the position of the horizontal tail trim. We have here is the transporter. You can see instead of the terrain, you can see other aircraft flying around you. Here in the navigation display using the transmitter and receiver. We have the weather and terrain radar here, some radio and communication panel to transmit in the high frequency VHF channel. Also we have the rudder trim here, the vertical tail trim, and the ailerons and spoiler trim. The fire extinguisher for the engine, the fuel control to the engines. We have the parking brakes here set as I told you, down and up. And also we have the stabilizer trim position, pitch down and pitch up and pitch down. We have the autopilot disconnect and the alert trim. So I'm gonna show you the thrust levers now. I'm gonna show you this switch also is here. We have the auto throttle disconnect switch here with these thrust levers. You press this switch, you disconnect. We have the takeoff go around switch, and we have I'm going to show you also we have the thrust reverses. So this engages the thrust reverse. You will see the signals in the upper ACAS and indication controller system. We have reverse thrust now. So if we land, we can use the thrust reverse to slow down the aircraft. So you can see the reverses being opened here and here, both engines. So we can disarm this like this. We can open it again, just show you how the blocker door open here and here also. You can see the blocker door again. Disarm it again. So this is the general management of the thrust reverse. So I'm gonna come now inside. I'm gonna show you a little bit of the engines, the thrust, how to use. You can disarm the thrust reverse. So you see again how to use the thrust reverse. So this is speed brake also we need sometimes. So you can see here we have the fabrics, we have the engine indications. So I'm gonna talk to you about the engine indications. You can see the flaps here, you can see the duct pressure, the outflow valves, the landing gear here, very important. External retract, the alternate gear here. We have the alternate gear. We have the auto brake system here. We can set if we like some other terrain override, flap override. This switch is also in the limits for external retract, the landing gear. So we have the outflow valve, we have the total fuel inside and the temperature of the fuel. So I'm gonna show you now the engines. So we use the engines when we move the engines into a new position. If we move them all the way forward, you will see the engines, the thrust levers position commanded, and here's the commanded position. You can see the difference between the commanded and the actual thrust. It takes some time for the engines to spool up and spool down. We have the N1, which is the low speed, low pressure compressor stage of the turbofan turbojet engine, and the limits, the green and the red and the yellow for takeoff, and some no exit limit. So we have the exhaust gas temperature. We have two engines, one installed per left and right wing. We have the outflow pressure, also used for cabin pressurization system. The N2, which is the high-speed, high-pressure compressor stage of the turbofan turbojet engine. The N1 is the low-speed, low-pressure compressor stage of the turbofan turbojet engine. The fuel flow per engine per hour in thousands of kilograms or pounds. The oil pressure, oil temperature, oil quantity, and the vibration of the N1 or of the N2 stage of the turbofan turbojet engine. So this is the general beginning management of the engines. So you can see the thrust levers here, so we can activate the thrust. So we use the thrust levers. We command the funnels. When we move the thrust levers, we command the FADEX new thrust settings. The FADEX are the full authority digital electronic control computers. One installed per engine, dual channel redundancy. If one channel fails, the other takes over. Also, we have two engines, one installed per left and right wing for thrust symmetry. So and redundancy. So. We can see that the FADEX, the full authority digital electronic control computers control and display the N1, which is the low speed, low pressure compressor stage of the engine, the exhaust gas temperature, the N2, which is the high speed, high pressure compressor stage of the turbofan turbojet engine. We have the low speed compressor and turbine, and the high speed compressor and turbine, high pressure and low pressure, and also we have this stuff. We have the fuel flow per engine per hour. I have the oil pressure, oil temperature, and oil quantity, and the vibration of the engine. All this using the FADEX. Also the limits, the green limits for takeoff, the red limits of the N1 and the N2. We have also the FADEX also regulates the outflow valves from the engines. If we have an overpressure inside the engines, we will open the outflow valve to relieve the pressure inside the engine. If we have an underpressure, we will close it to increase the pressure inside the engine, and also regulate it this way. And the fuel burn if we have the engines, because the engines are turbojet, so the intake air which they pressurize it, and then they make their air fuel mixture after they pass some blade stages. So this needs to have the right ratio. So we need the right pressure inside the engines. Also it monitors the engine start and the engine shut down, and regulates these limits also, and some other systems maybe. So I'm gonna show you this how to use the thrust levers. So we need the thrust from the thrust levers here for takeoff. We need to set the right takeoff, and after takeoff set the autopilot, the correct airspeed guidance. So uh, this aircraft right now, the Boeing 777-300 ER model that we have is having 254,000 kilograms of weight, fuel plus passengers plus cargo. So we have 254,000 kilograms of 583,000 pounds. So from that, 46,000 kilograms or 102,000 pounds is the fuel on board. 30% of the total fuel we can carry only, so we are below the maximum fuel weight. Also we are below the maximum takeoff weight, way below it. So we have only 20,000 kilograms of passenger and cargo. We are below this limit also. So our aircraft weighs 254,000 kilograms, below the takeoff maximum weight. So when we are in the runway, we need to develop an airspeed of about 154 knots or 270 kilometers an hour with this aircraft for takeoff. So we need also to use 15 degrees of flaps and 4 degrees of horizontal stabilizer tail pitch trim. So we need 270 kilometers an hour or 154 knots. That's for takeoff. We need to overcome the stall speed. The stall speed is an airspeed below which the angle of attack of the aircraft and the airfoil, the forward wings of the aircraft are gonna stall. So they're gonna develop the lift. The lift is the force that overcomes the weight of the aircraft that is equal to the mass times the acceleration of gravity. So the aircraft is gonna start falling back into the ground. We won't gonna take off. So we need to overcome the stall speed, and we need to develop an effective lift. We have the lift when we develop this airspeed 270 kilometers an hour for takeoff, a little bit higher for landing, and when flying also. Maybe using some more flaps or less flaps. So I'm gonna show you also that I'm gonna show you the lift created from the forward wings, how it is created. So you understand the general management. We need the thrust levers to move the aircraft forward, and we need to accelerate. So we're gonna use Newton's first, second, and third law of motion in kinematics from physics, Newton's physics, and then also we're gonna use also aerospace engineering and aeronautical engineering and some other principles like Bernoulli fluid physics. So I'm gonna show you also that and some mathematics. So we're gonna use these equations to find some interesting things about the aircraft when it's flying. So I'm gonna show you also the flight controls here and after that. So you can see the exterior view here of the aircraft. You can see the wings. So we need these forward wings here are responsible for creating the aerodynamic lift that I told you. We have the thrust from the engine, the forward thrust. The engine only can push the aircraft forward because it's an airliner. They cannot make it climb vertically. So, like a fighter jet. So, you can see we need the wings also to develop this. After we develop this airspeed, we have the airstream, the airflow, this air mass from the forward, from the leading edge of the wings all the way back to the trailing edge of the wings. It creates a jet stream. So we have this stream of air. You can see the wings. The bottom surface of the wings is more flat, and the top surface of the wings is more curved. It has a higher curvature. So the bottom surface of the wings, we have the airflow of the airstream is moving with lower airspeed, so it develops an overpressure, a higher pressure below the wing, and also because of the curvature in the top of the wings, we have the airspeed of the airflow of the air mass is moving with higher airspeed above the wing. So it develops an under pressure, a lower pressure. So we have higher pressure below the wing and lower pressure above the wing. So this makes the aircraft to bubble up into the air. It's pushed up from the wing, and it's having under a gap under a lower pressure in the top. So this is the lift force, and the lift force we have the wings, the total weight of the aircraft over the surface area of the wings. You can see the thrust from the engine, the vectors. So we have the leading edge and the trailing edge. You can see some other components. We have the mean aerodynamic chord of the wings. If we position at 25%, we can find the maximum aerodynamic lift position. It's also the position where the stall begins, where the aircraft starts to stall and losing its ability to fly. So maximum aerodynamic lift position, also the center of gravity of the aircraft and the center of geometric positioning. So aerodynamic lift, a maximum, and center of gravity here. So we position some other vectors here and here from the center of gravity all the way back to the horizontal tail and the vertical stabilizer of the aircraft. We have the moment arm of the aircraft, and also from the center of gravity to the left and the right wing, we have also moment arm for turning left and right. We have the moment arm for climb and descent and for making turns. So the moment arm is the force that is equal to the distance from the center of gravity all the way back to the horizontal tail over the surface area of the horizontal tail times the airflow mass per second. We have also airflow deflection like this. So it's times also the acceleration of gravity. So this is the moment arm force that will use the horizontal tail and the vertical tail to steer the aircraft, and the ailerons and the spoilers in its wing. So this is a general explanation of the aerodynamics. Also using the Bernoulli's theorem and Newton's physics. So I'm gonna come now to the flight controls. You can see the flight controls. So I'm gonna explain some for the flight controls inside the cockpit. I'm gonna show you now. After this thrust, I'm gonna show you the flight controls now. How to use all the flight controls. So you can see I'm using I'm gonna show you how to use the flight controls using this side stick here. I'm having the display of the computer. I'm also having a side stick for controlling the elevators, the vertical stabilizer, the rudder, and the ailerons and the spoilers of the aircraft, the Boeing 777. See how here so control the yoke of the Boeing 777. So I'm gonna show you now. You can see inside the cockpit we control the yoke like this and the rudder pedals for steering the aircraft. So I'm having this side stick here, the Lszh Extreme 3D. For the simulation you can leave it in the neutral position. For the flight controls you can move it up. For climbing, use the elevator up, use the elevator down. For descent, bank roll left and bank roll right. So you see the position of the side stick is proportional to the position of the flight controls inside. Also the other side here is moving alongside with that. So we have them interconnected between the left and the right, and also control the ailerons and the spoilers. We can make bank roll, the vertical stabilizer, the rudder. So this is the general management of the side stick and the flight control system of the aircraft. You can have directional control in flight after you have effective lift from the wings and forward thrust from the engine. So if you fly with more than 270 kilometers an hour, let's say. So you have also the stabilizer trim here, the horizontal stabilizer. You have the thrust levers, the engine. So the stabilizer is very important. It balances the aircraft using the center of gravity and the horizontal tail position. The airplane. Now I'm gonna show you the outside view of these things. Then I'm gonna come to the engine start demonstration. So you can see the outside view. Here we have this is nicer view of the outside of the aircraft. You can see again the flight control. So I'm gonna show you how to control all these systems for having directional control in flight using this side stick again. Here that I'm having the side stick, the Lszh Extreme 3D. So you can see it again. So you can see I can position again the elevator and the ailerons and the spoilers. I can control them like this. Pitch up, pitch down, bank roll left, bank roll right, and the vertical stabilizer of the rudder pedal. So I'm having coordinated flight stabilizer trim also, and the thrust levers again. So this is the general view of the systems. So I'm gonna come now inside the cockpit, show you how to make the engine start demonstration, show you the overhead panel, the flight management computer, and then flying the aircraft for a small flight. So we come over here again. You can see we are about to start the engine start demonstration now. So I'm gonna come inside the aircraft a bit more safe this time. I'll have to show you the overhead panel a little bit faster. So I'm gonna show you more general view of the overhead panel again. I'm gonna show you how many minutes we have, like for this video to end. We have like we have pretty much time right now. We have more than 13 and 18 minutes, so we have about 33 minutes left to finish this video. 32 minutes approximately. So in here again, the Adiru, the primary flight control computers. We have the electrical left and right engine, IDGs, integrated drive generators. So I will explain a little bit about this. The IPU we can use for starting the battery. So when the engines work, besides creating the thrust that moves the aircraft, that propels the aircraft forward, also moves inside the gearbox of the engines. The IDGs, the great drive generators, we have one installed per engine, and the hydraulic pumps, we have electrical power, electromagnetic alternators, IDGs, the great drive generators. So it's 120 to 200 volts. Electromagnetic induction, alternate current, 120,000 kilovolts each engine, or 100,000 watts, 400 hertz frequency. Constant frequency, we can convert this current into direct current, this alternate current direct, using the transformer rectifiers. We also have the backup generators, 35,000 kilowatts each, and the APU another 120,000 kilovolts, or 400 hertz frequency alternate current. We have the batteries, 38 volts to 48 ampere hours direct current. You can convert the direct current into alternate using the static inverter. So we have the hydraulic pumps also. These are controlled from the engines gearbox, the receipt torque, horizontal torque force, just to move these pumps, and the grid drive generators for the electric current. So we also have the outflow pressure from the engines, the pressurizer used for also for cabin pressurization, for organizing the ice and air conditioning, and also for hydraulic fluid pressurization. I'm gonna show you now. So we have over here, you can see the left and right IDG, the degree drive generator. We can turn on and off like this using the switch. So if I come here on this display, you will see the generators of the electric generator and the backup. So we need to reconnect. We have the APU on right now. We start. We have the batteries here. I told you we have the window here. We have the hydraulics here. You can see. We have the air system, the air pressurized hydraulic, electric. We have the engine driving. The man, the primary, we can turn on and off. Other way, you can see like this. So we leave this in the on. We have the ram air turbine. We have also here, I'm gonna show you, we have the electronic engine control for the engine, normal and alternate modes, the fire extinguishers for the car going down the APU. So we can use the auto start. We can turn on and off the auto start system. So we have the electronic engine control computers mode. We'll leave the auto start in the normal and on. We have the fuel jettison. We can dump some fuel if we arm this. Select the nozzle to dump the fuel to remain here with this switch. We have the cross switch. This is the left wing and the right wing fuel tanks. The line for the engine. The center tanks, which are empty. That's why they display this fault. Pressure. We have the forward and the aft pumps here. You can see the aft and forward. Now we have the pressures. We have we're gonna turn on both for the left and the right wing. I'm gonna show you later in the displays. We have the wing and engine at the ice, the lighting system. So you can see the wing and engine at the ice systems here. You can turn on and off and auto. So we have the windshield wipers also on this side. So we have the this is important. This is, so you can see the air conditioning. We have the pressurized air from the left and the right engine. We have also, this is the isolation valve we can use for cabin pressurization, wind and engine at the ice, air conditioning. You can see wing and engine ADIs, hydraulic air drive and C1 and C2 and cabin pressurization. So we have also the APU. We use the APU pressurizer for starting the engine. So if I turn off all these systems, you will see the faults here. The bleed pressure, the pressurizer from the left and right engine. Right now is off. So we'll use some system. We also have no duct pressure for the cabin pressurization system, so we cannot pressurize the cabin of the aircraft after takeoff. So we turn back this on. The isolation valves, also the packs, left and right packs. So this is the cabin pressurization system. You can see in the auto if we use the manual. You can see the man displayed. We use the outflow valves open and close when we climb or descend to pressurize and depressurize the cabin and select the landing altitude. So this is the general view of the overhead panel. Most of the systems I'm gonna come now. Here I'm gonna come in this view. I'm gonna show you also. Wait, I have to set the flaps for takeoff here. Flaps fire. So I'm gonna set them at 15 degrees. Ready? One more time. 15 degrees over there. So you will see them displayed here at 15 degrees in the display here. So this is the general view. We go now in the multifunction display here. We have CDU and this display, so we can turn on and off this display. The modes we can use. So we have display. We have the engine. We have the status. You can see we have the APU start right now, and it's running the hydraulic soaps and the oxygen inside the aircraft. The checklist here, what we need to do just before start. For instance, set up these items, and the checklist is complete. We have also the non-normal menu. If we have a failure inside the aircraft system, we have the communication. Again, the navigation system, the synoptics. So we have the doors. You can see the doors of Boeing 777 here now are closed and the cabin can be pressurized. We have the pressure in the left and the right and the nose wheel, the pressure inside the tires and the pressure of the brake. Again, the electrical items to the left and the right IDG. The great drive generator, the backup generator is on. We have the green and the APU and the contactors. We have also the main battery here, the voltage, and the APU battery, the voltage. So you can see the diagram that is working. So we have the hydraulics now. You can see we have the left and the right engine. We have the hydraulic pressure 3000 psi. We have the electrical backup and the pressurizer system from the engines, the pressurizer for the hydraulic fluid, the primary. So this is for flight controls, rudder, elevator, ailerons, spoilers, landing gear and parking brakes. And we have now we have the hydraulics I told you, the pressure and quantity. We have the shut-off valve. So we're going to fuel left and right wing, tank, the center tank, the crossfeed valves. You can see the engine here symbol and the line. We have the low and high pressure fuel valves on. The crossfeed means the left wing and the right wing can feed either way, either engine. The APU also is on. The minimum fuel temperature. You can see the center tank. This yellow crosses means it's empty. So we have about 46,000 kilograms or 33,000 kilograms since left. You can see displayed with pounds, 50,000 pounds and 50,000 pounds. So we have their systems here. You can see the left and the right engine, the pressurizer from the engine. Used for hydraulic fluid pressurization, wheel and engine ADIs, cabin pressurization, air conditioning and ventilation, and also we have the APU here. This is for engine start. We use the inverse. We will pressurize the engine starter. So if I move the thrust levers forward, you will see the pressure inside the air engines increasing. So the outflow pressure also increases. So move the engines down. I'm gonna come to the flight controls now. You can see the left and the right wing, the body of the aircraft, and the horizontal tail and the vertical tail, the stabilizer trim. So I can move, extend the speed brakes. You will see the speed brakes are extended. I can move the ailerons, the side controls around. You can see the movement. We have no failure. So this is working right now. This flight control system, and the rudder pedals also work on the other side. So we have this nice review of the cockpit of the Boeing 777. So I'm gonna come now to the modes, the engine. So I'm gonna make the engine start now. I need to shut down the engines, so I'll shut off both engines, the fuel control, turn off the left and the right. So we have a couple more minutes left for this flight. You will see the engine shut down message here. The N1 decreases the exhaust gas temperature. Also we have the engine shut down, it's gonna go down to the zero. We have no fuel flow, and the N1 also decreases. Take a look from outside this aircraft. You will see the engine starts pulling down now, and it stopped working. So I need to make the engine start now. I come in the overhead panel. You can see the reconfiguration. So I'm gonna start the left and the right. Engine start, auto start system is on. So it's gonna admit pressurized air from the APU. So it's gonna increase the spinning of the engine and the exhaust gas temperature. When above 20% N2 pressure, we can see the spinning of the engine has begun. The right wing and the left wing engine. Here the left wing engine spinner also. So we can admit fuel now. We can let the fuel flow left and right wing engine. So we're gonna have here the fuel flow and the N2 increase rapidly on all the factors. So here we go, we have the engine start. You can see the spinning, and here we go, both engines left and right wing. So now we need one last item to do. Before takeoff we need to set up the flight management computer here, the initial the menu. So we go in the FMC, we have the model and the position initialize, Lszh, we set the reference airport. If we need, we set the inertial position. So we have the GPS inertial reference here, the coordinates. So we have the zero fuel weight and gross weight, the reserve fuel 5%, and the cruise altitude 25,300 here 300 feet. We're gonna set this 35,300, and the cost index 100% also. Minimum fuel temperature. So we have the route from this airport, Lszh, back into this airport. We're gonna use this runway also, runway 14. So we have this route. We're gonna use now departure and arrival from this runway. France, this is with Alpha, and then arrival Lszh 14 approach, trans the Negri 1 Alpha, trans Amity. So we have the legs, activate and execute. So we need to set the flaps and the center of gravity of the aircraft. So we have the takeoff speed activated for this weight and this runway. I can see the runway, also the length, and if we have other factors. So the legs, the takeoff, we're gonna follow this route. So we're gonna see the route inserted here in the primary in the navigation display. Excuse me. So we are just ready for taxiing to the runway now. So we have the outside view again of the aircraft. You can see where we need to go now to the runway. We're ready for takeoff. So we need to advance the thrust levers and disarm the parking brakes. So we need to use the steerers here for steering the aircraft in the runway. Doesn't need so much thrust. So the runway is open now for us. We use the pillar here. We have like a few more minutes to go. So we need to align with the center line and the Lszh localizer. So we use the parking brakes again. We have a few more minutes. You can see where we are. We have like 15 more minutes to go for this flight. So we only need to set up this again. The range here, we set the autopilot is on. We have the LNAV. You can see the route here. We have the Lszh localizer, the route, the airspeed, and the altitude, the flight director. So you can see the terrain scan here from the radar in front of us. So we advance the thrust levers forward to the takeoff position. So we have the N1. It will reach the takeoff. We will stabilize and reach the takeoff point. So we have like 15 more minutes to go. So we are 90 knots right now. 100 V1, we rotate, and V2, we have the takeoff of the aircraft. So here we go. We have the positive rate. So we need to stabilize the takeoff. We need to retract the landing gear. We have positive takeoff. Positive rate of climb. We have stabilized the engines here, as you can see. So we are 2000 feet, 2200, 2400 feet, you can see, above the ground level. We are about, the airspeed is 190 knots. We are 4000 feet above the sea level, and we climb with 5000 feet per minute. You can see the stall speed, the yellow and the red margin. We need to avoid, because the aircraft is going to start falling. We have the flaps limits, also the red marking here, and the red is the stall speed, the ground speed. So we have the navigation here, the terrain, we have the waypoints, we have to follow the route. So we keep climbing like that. We have the flight level change speed now here. So this is gonna make the climb a little bit slower. So we keep climbing like this. You can see how we steer the aircraft. We need to navigate to the next waypoint. So we're gonna have the view outside now. A nice view outside of the aircraft. You can see other aircraft flying around us. You can see the airport below, a view of the Zurich and the Switzerland. This beautiful view. So this is a nicer view of the Boeing 777 300ER airplane. So maybe keep climbing. So we keep climbing like this. A nicer view. We keep flying now with about Mach 0.5, or about 600 kilometers an hour, or about 250 meters a second. So we have also the night view, this nicer night view of over here, the galaxies and the star size. So this is our spacecraft for the night, the Boeing 777, 600 kilometers an hour, overflying out here the Switzerland, the Swiss Alps. So I'm gonna come inside again. show you a little bit more inside. One more view here like this. So I'm gonna come now. We have to steer back into the lake, the St. Gallen Lake. So we climbed 16,000 feet. So we have 5 and 2 7. We have like 11 more minutes left to go for this flight. So I'm gonna show you now how to steer to the next waypoint. We need to set the direct tool and execute this. So now we're gonna fly directly to the next waypoint. 17,000 feet. Also this max speed. You can see I'm using the stabilizer trim here. Stabilize 31,000. So we can see the navigation here, 31,500 feet. You can see the rate of climb here. I need to climb a little bit higher. And also retract maybe some flaps to a higher position. So now we need to steer into the next waypoint here. 33,000 feet here. We cross 33,000 feet. So we're gonna have the handrails now in the contrail. So we have this magnificent view. We have the handrails and the contrails here. So you said 34,000 feet. So we now fly with higher speed, about 700 to 800 kilometers, or about 270 meters per second. We're gonna be overflying the lake here. We almost reach our climb altitude. So we also need to come back into the airport for landing. So we have the German in this view. On this side we're gonna overfly the lake. We actually need to steer in this waypoint over here and then come back for landing. So we have the handrails and the contrails. You can see we're flying here the Switzerland, 35,000 feet. So now we're gonna make it with 300 meters per second, or about 900 kilometers an hour. We're gonna increase our airspeed again. So we have this nicer view now of the Boeing 777. We have also the frozen vapors here. You can see this nicer view. We are 36,000 feet right now above the ground level. So we need to start descent in a while towards the airport. So you can see we have the Germany, the Bayern Munich and the Bavaria here, and the St. Gallen Lake. So this is our spacecraft for tonight, the Boeing 777. This is its magnificent galaxy view. So now go back to the airport with 900 kilometers an hour, about 300 meters per second. So we need to increase the airspeed here. And retract the flaps here. We fly manually, and we need to fly to the next waypoint now towards the airport. I will keep flying manually. So we have We have like 6 more minutes left for this flight, so we need to be a little bit more swift. We fly with about this airspeed. Now we need also to descend lower. We fly with about we need to come to a descent now. Decrease the airspeed and select lower altitude for descent. Use the flight level change, and we will have the idle thrust. I'll move it by the auto throttle system, so we have a few more minutes, like 6 more minutes left to go for this flight. It's gonna be marginal completely, so we cross 33,000. Again, we have this spacecraft for tonight, 900 kilometers an hour, 300 meters a second, a magnificent airspeed. So we keep descending. I'm gonna use a nicer range now, 30,000 feet. $19,000. $17,000. So maybe we're gonna use the landing gear now. Extend the landing gear to slow down a little bit. We're gonna use a shortcut for landing. Actually, we keep flying with about 900. No, and now we slow down. We need to slow down. We fly with 500 kilometers an hour, so we're gonna use also the Lszh, the vol localizer, for this approach. So I'm gonna have also some flaps here, and also decrease the airspeed here to the approach landing airspeed. So we have the reverse here. We always find the reverse. So we have like 3 more minutes left for this flight. So we need to come for the landing. So here is the general view where we are right now. We're going to the runway. So we use a nicer view here for the landing. So we have the Lszh localizer here. You can see this is an Lszh localizer landing. So we are aligned with the runway, the Lszh localizer, and also the glide slope. Okay, you'll see the radio altitude above the ground level in a couple of seconds as we keep descending. So we are 2500. We have the radio altitude 2500 feet above the ground level. Use idle thrust now. Need to align. Use also the rudder pedals for that to steer with the rudder. Align with the Lszh localizer. Just before touchdown. We are a little bit higher, but no problem for us. just leveling off now and flaring for the touchdown. So here we are, idle thrust, just touchdown. We have the parking brakes and full reverse thrust. So here we are, full reverse thrust, just touch down the runway. So we made it. We also have a couple of minutes video time, so we made it nice. Just landed on runway 14, Zurich International Airport, as you can see, full center line here. You can see also we have the landing gear here. The nose wheel, the tire is not breaking. The nose wheel and the tires of the nose wheels no damage at all. Also the landing gear, the right and the left landing gear, the tires no breaking. So we are level wheels and nose wheel and thrust reverse for this landing. You can see also this view. The nose wheel is safe. The nose wheel, the metal parts, there is no breakage like some other people do. So this is important for landing a Boeing 777. So I'm gonna show you that. So you can see we have no faults inside the cockpit. We have. So that was Thomas Hatsios, the pilot captain flying the Boeing 777-300 ER into night flight from the international. Thomas Hatsios, the British American pilot flying the Boeing 777-300 ER tonight. Thank you very much.